Hello and welcome to the third part of the tutorial on optical flow wrapping. On Real Project, you may have dozens of scans of facial expressions for each character. In practice, 80% of these expressions are relatively simple. I've been showing you how to process them in the previous part, but the other 20% is what I call extreme expressions. Things like screaming, closing eyes, or compression are very hard to solve. Skin contracts, stretches, and changes its color so much that it's very hard for optical flow to find proper correspondences. In this part, I'm going to show you a couple of tips that can help you. Let me start with the same project that we were using in part 2 of this tutorial. Here we have the neutral base mesh, a polygon selection, an optical flow wrapping node, and a target scan. This time I'm going to use an eyebrow up expression. What's special about this expression is the eyelids that represent large non-uniform deformations. Let's go ahead and run computation. As you can see, the upper eyelids are completely misaligned. The most straightforward solution is to specify a big number of control points. That's exactly what we are going to do. Let's create a select points node. First, we need to specify a set of control points that will keep eyelids in place while the eyebrow goes up. Traditionally, I put 2 points on the sides and then set a point in the middle. I'm going to repeat the same process for the left eye. Okay. Let's plug point selection to the optical flow wrapping node and click compute. Here we go. The eye contours look nice. However, in this area on the forehead, we still have some misalignment. What we need to do is spot which skin features were matched incorrectly and pin them with control points. Okay, this number of points should be enough. Let's click compute again. Alright, now it looks better. If we switch between the models, we can see that the alignment is pretty nice. Now let's take a look at more of an extreme case. Here we have a screaming expression. Such expressions are very hard to process even with a large number of control points, so we need to use a different strategy. It's a common practice that all the characters in the same project shares a common topology. Imagine we already had one character with a complete set of expressions that was carefully cleaned up and sculpted by a 3D artist. The idea is to take an expression of the existing character and to transfer it to Alex. Then we can use that approximated expression as a starting point for optical flow wrapping. You can use any custom set of blend shapes, but for now I'm going to use a standard set that comes with the wraps gallery. First, we need to find the most similar blend shape to Alex's screaming expression. I think this mouth open expression should work. We also need to load a neutral blend shape. I'm going to rename my nodes accordingly. In order to do retargeting, we're going to use a blend shapes node. If I start changing weight parameter, you can see interpolation between the blend shapes. First, we need to plug Alex's neutral mesh to the third input of the blend shapes node. The node turned red. If we press the middle mouse button over the node, we will see an error message. The message says base geometry and blend 1 have a different vertex count. It happened because Alex's mesh was originally subdivided and has a different number of vertices. Since all the inputs of the blend shapes node should have the same vertex count, we also need to subdivide the other two meshes. Let me also apply a texture to the mesh and turn off wireframe. Now we can transfer the screaming expression from the generic character to Alex. If I come over here and increase the weight of Alex's mesh to 1, that will make the generic mesh look like Alex's face. Now as we're increasing the weight of the mouth open expression, it's being added to Alex's mesh, simulating his screaming face. As you can see, our simulated expression is pretty similar to the real one. I'm going to use this approximate expression as a starting point for the wrapping process. To do that, we're going to plug the result of the blend shapes node to the first input of the OpticalFlowWrapping node. Let's click Compute. Alright. The result is pretty good. I think adding a few control points should make it perfect. Let's create a select points node. Don't forget to plug inputs to the select points node in the same order you plug them to the OpticalFlowWrapping node. I'm going to add a few point correspondences around the lips. Alright. Let's click Compute again. Here we go. Let's compare it with the target scan. Now it looks perfect. Let me also say a few words about the parameters of an optical flow wrapping node. One of the very important parameters is resolution final. Wrapping is computed in several steps. After each step, the resolution of virtual cameras is slightly increased, starting from the resolution initial value to the resolution final value. Setting bigger resolution leads to better accuracy, but at the same time drastically increases computation time and memory consumption. I won't recommend to set that value higher than 900 by 900 pixels. For now, let's set it to 800 by 800. The second parameter worth mentioning is optical flow smoothness final. Sometimes you need to increase it for extreme expressions when you see that optical flow finds wrong correspondences even though you provided plenty of control points. Let's set it to 6. One last parameter you may need to tweak is smoothness final. Just like with the standard wrapping node, it prevents the mesh from being distorted. Let's leave it to default for now. Be aware that increasing the smoothness final and optical flow smoothness final parameters leads to smoother mesh and thus better robustness, but at the same time the fitting becomes less accurate. Let's run computation again. Okay, here's our final result. Please also note that most of the parameters are optimized to the model's a centimeter scale, so it's highly recommended to keep your models in centimeters. During this series of 3 tutorials, we learned how to process different facial expressions. For these 4 models, I also projected textures from corresponding scans. One great advantage of the optical flow wrapping process is that all of the projected textures are now nicely aligned within the same UV space. It means that we can blend not only between geometry, but also between textures. Let's create a blend shapes node. First, we need to plug all the meshes. By default, it only blends between meshes and leaves the texture unchanged. One cool feature of the Blend Shapes node is that it supports a real-time preview of texture blending. All we need to do is enable fast texture blending preview mode. Please note that the preview is only visible in the Editor tab and does not affect output geometry. Note how this preview reveals some nice wrinkle and blood flow effects on the skin. Alright, that concludes the tutorial. Thank you for watching and stay tuned for upcoming videos.